Okay, this is a review of the binomial expansion where the formula can be found on the formula sheet. It's more towards the bottom on the left, just above the bell curve. If you go down to the binomial theorem here on the bottom, okay, you'll notice that it's a plus b raised to the n, which means it's a binomial raised to a power. It's a summation of, because you need to take all your answers and actually sum them at the end to get your ending. It's a combination of n things taken r at a time, a raised to the n minus r, b raised to the r. If you look at the characteristics here, where it says there are n plus 1 terms in the expansion, powers of a will go from n to 0, and the powers of b will ascend from 0 to n. So one side's going to go down as one side's going to go up. The powers of a and b will always equal the end, and the coefficient can be found by using the combination. Well, the best way to do this is to get right to it. So let's go to a couple examples. So, using the binomial theorem, let's expand m plus 2 to the third power. All right, so let's assign our values there. Knowing that m is in the a spot, so m is a, 2 is b, and my n is 3. Okay, now that I have everything, I will be able to begin. Okay, so it's a combination of, starting off with a combination because we're going to take the summation at the end, of 3 and r in the combination according to the summation here starts at 0 and goes to the end. So it's 3, 0 times my a value, which is m, raised to the n minus r, 3 minus 0 is 3, times my b value, which is 2, raised to the r value, which is 0. Okay? So then we've got to do a combination of 3, 1. M raised to the second, 2 raised to the first, following the rule. C, 3, 2, because we have to keep doing the combination until my r actually is my n, which is 3. So I have m to the first, 2 to the second. Combination of 3, 3. Okay, this will be my last one because my n and my r match. Times m raised to the 0 times 2 raised to the third. Now let's take a look at this. Was that true? Was my a value, which is my m, did those exponents descend? And did my b value, which is 2, did those exponents ascend? Yes, they did. All right, so then you're going to put each piece in the calculator so that you can summation this. All right, so on the calculator, combination of 3 things taken 0 at a time is 1. M to the third power is m cubed, times anything to the 0 power is 1. Combination of 3 things taken 1 at a time is 3. M to the second power is m squared. 2 to the first is 2. 3 things taken 2 at a time is also 3 for a combination. M to the first is m. 2 to the second is 4. Combination of 3 things taken 1 at a time is 1. M to the 0 is 1 because anything to the 0 power is 1, and 2 to the third is 8. So now we've got to see what these equal. So it's like a 3-step process here. So 1 times m cubed times 1 is m cubed. That was easy. 3 times m squared times 2 is 6m squared. Okay, that wasn't too bad either. 3 times m times 4 is 12m. 1 times 8 is 8. Okay, now the last part is to summation it. So we actually have to sum it. There are no like terms, so we're going to actually write it as m cubed plus, because they're all positive, 6m squared plus 12m plus 8. So there is my answer to m plus 2 cubed. And then it said, what is the sum of the coefficients? Well, the coefficients in this expression is a 1, because the 1 in front of the m cubed, plus 6, plus 12, plus 8. If I sum the coefficients, I end up with 27. All right, what happens if I want only a specific term in an expansion? Same formula, but this time I'm not summing it because I only want a specific term. I wouldn't use this formula here. It's just a little bit too confusing. I would use the same formula, combination of n things taken, r at a time, a raised to the n minus r, b raised to the r. So looking at that binomial, 3x is my a, 2 is my b, and 5 is my n. I need the fourth term, so I'm not going to do every one. And just like we saw the last time, we got to do a combination until my n and my r meet. So it would be a combination of 5, 0. That would be my first term. I don't want the first term, I want the fourth term. 5, 1 would be my second. 5, 2 would be my third. 5, 3, that would be my fourth term. So this is the one that I'm going to finish. Times my a value, which is 3x raised to the n minus r, which is 2, times my v value, which is 2 raised to the r, which is 3. So now I've got to put each portion into the calculator to see what I have. Okay, combination of 5 things taken 3 at a time is 10. 3x, the whole thing squared, would be 3x times 3x, which is 9x squared. 2 cubed is 8. 10 times 9x squared times 8 is 720x squared. So if I was to write that whole thing out, the whole expansion, the fourth term in that expansion would be 720x squared. All right, let's take a look at this one. What are they talking about? Middle term. Well, that's just it. I want the middle term of that expansion. Okay. My a value is the 2m. My b value is the -5, and my n is the 6. So how will I find the middle term? Well, I'm going to have to start them all off. Let's see. Combination 6, 0 is the first. 6, 2, 6, 3. And remember, you go until the n and the r match. 6, 3, 6, 4. 6, 5, 6, 6. Oops, I skipped one. My mistake. I needed to do 6, 1. And I'm sure all of you have it. I'm sure you do, since this is a review. So it's a combination of 6, 0, 6, 1, 6, 2, 6, 3, combination 6, 4, 6, 5, 6, 6. Okay, I need the guy in the middle, so that would be this one right here. So that's the only one I'm going to finish. Times my a value, which is 2m, raised to the n minus r, which is 3, times my b value, which is a -5, raised to the r, which is also 3. I'm going to put that, each piece, into the calculator, and let's see what I end up getting. Okay, so I'm going to end up with combination of 6 things taken 3 at a time is 20. 2m cubed is 8m cubed, because 2m times 2m times 2m is 8m cubed. -5 cubed is a -125. If I multiply that together, I'm going to end up with a -20,000 m cubed. So if I was to do the whole expansion, that term would fall right in the middle. So there's a nice little review on the recursive formula. The binomial expansion. And again, the formula for this binomial expansion is found on the reference sheet, so it's something you don't have to memorize. It's just something you have to know how to use. So please feel free to view this video as many times as you need.